Okay, we're looking at verifying trigonometric identities, but this time we're going to be transforming both sides of the equation so we can show that the left-hand side is equal to the right-hand side. So the first question we have, we need to verify that cosecant squared theta minus cotangent squared theta is equal to cotangent theta multiplied by tan theta. So left-hand side, so this is our left-hand side, and this is our right-hand side. So I'm going to look at the right-hand side first, and I'm going to just rewrite. So cotangent is 1 over tan theta, and tan we'll just leave as tan theta. Well, these actually would simplify to 1. So on the right hand side, we have the answer as 1. So we're going to rearrange the left hand side to equal 1. So the first thing, if we look at, we have squares. So we're going to look at the Pythagorean identities. And cosecant squared, that is equal to cotangent squared plus 1. So I'm going to change that to cotangent squared plus 1. And then I'll just leave minus cot squared as it is for a second. And now we'll change cotangent. This is sine squared over cosine squared theta. We've still got the plus 1. And then we can change this cotangent here to sine squared theta over cosine squared theta. Now I want to put all my my values over the same denominator. So if I multiply the 1 by cosine, so I can put it all over cosine, I'll have sine squared theta plus cosine squared theta minus sine squared theta. So sine squared theta and cosine squared theta, again looking at the Pythagorean identities, we know that that is equal to 1. So I'm going to replace that, and that is going to be 1 minus sine squared theta over cosine squared theta. So again, the Pythagorean identities, look at that one first, and we can see that we have 1 minus sine squared is actually equal to cosine. So I'm going to replace this with cosine squared theta, and that's over cosine squared theta, and they will simplify, that's equal to 1. So the left-hand side is equal to 1, and the right-hand side is equal to 1. So both sides equal 1. Okay, so this question here, so verify 1 minus tan to the 4. So when we're looking at big values like this, the first thing we want to think about is factoring. So I'm just going to factor both sides. So we've got 1 minus tan 4, and this will factor to 1 minus tan squared theta and 1 plus tan squared theta. And then on the right hand side, we can factor this by, so we have 2 sec squared minus sec 4. And if we factor this by sec squared theta, we'll have 2 minus sec squared theta. So we need now to make the left-hand side equal the right-hand side. So always looking for Pythagorean identities first when you have squares. So we're going to change the one there. We're going to leave that there, and we're going to change the tan squared theta. This is equal to sec squared theta minus 1. And 1 plus tan is just sec squared theta. And 1, if we multiply this out, so we have 1 minus sec squared theta plus 1 and sec squared theta. So 1 and 1 becomes 2 minus sec squared theta. And we have sec squared theta. So we just need to change the order. So if I rewrite this the other way around, we have sec squared theta multiplied by 2 minus sec squared theta. And on the right side, sec squared theta, 2 minus sec squared theta. So the left-hand side is equal to the right-hand side. Okay, so another question here. We have cotangent theta plus tan theta is equal to secant squared theta over tan theta. So we need to look at both sides. So the first thing I'm going to do is look at the right-hand side. And we have sec. So we're going to change. I'm going to rewrite sec. So sec is actually 1 over cosine squared. And tan is 1 over tan is cot. And cot is cosine over sine theta. So if I just multiply those, so I've got cos theta over cos squared theta sine theta. So this is my right-hand side. So let's look at the left-hand side. So cotangent I can rewrite as sine theta over cosine theta. And tan I can write as cosine theta over sine theta. Now I need squared and these are not, so I'm going to multiply them both. So I'm going to multiply sine over cosine theta. I'm going to multiply this one by sine. So we'll have sine theta. And then I'm going to multiply the cosine theta by cosine theta. So if I do this, this becomes sine squared theta over cosine theta sine theta plus cosine squared theta over cosine theta sine theta. And from the Pythagorean identities, I know that sine squared theta plus cosine squared theta is 1. And I can write that over my denominator. They're both the same. So I have 1 over cosine theta. So what I need to do now is just multiply both by cosine theta. So if I multiply, I will have cosine theta over cosine squared theta multiplied by sine theta on our left-hand side. So this is our left-hand side. So if I rewrite that over here, so cosine theta over cosine squared theta times sine theta. So this is left-hand side. And on the right-hand side, which is here, we have cosine theta over cosine squared theta sine theta. So we have made the left-hand side equal the right-hand side.